Hi, thanks for joining us today. I'm Ryan Crawcor, a program manager on the Azure DocumentDB team, and joining me is a colleague of mine.
Hi there, I'm David Macagon. I work on the Partner Catalyst team. So my focus is Azure-related projects, and I work a lot with partners, and specifically data.
Cool. So this is, Azure is a very broad set of services. We're not going to focus on any of the other ones today. We're going to highlight and focus specifically on one of the services, which is Azure DocumentDB. So in today's talk, we're going to do a 5-minute lightning round of what is DocumentDB. How would you do an elevator pitch of what is DocumentDB? We're going to have a look at lots and lots of demos of how you can kind of get going, get started, tweak some things, change some things, and then we'll close up with, we'll wrap it up.
Okay, let's see if we can pull this off in 5 minutes.
Let's go. So DocumentDB lightning round.
So it's a document database, right?
That's it. What do you mean when you say document database?
So you know this NoSQL thing?
Yep.
Right, we talk about there's relational data. Well, maybe not everyone. So, okay, if you don't know, right, there's relational data, and then there's what this umbrella term of NoSQL is. So there's document databases, and key stores, and column stores, and graph, all these different types of databases. So Azure DocumentDB is a document store. And if you're interested in knowing what a document looks like, well, just look at the slide we're showing. It's really, it's a JSON document. It's a collection of key value pairs. So I think that's pretty much it, right?
Yeah.
So the other thing is with this document database, there's different ways to connect to it. So we have
so like most services in Azure today, there's a REST layer on top of them, and you can actually access that REST layer to talk to your service. So you can programmatically talk to different parts of the service, and the same thing with Azure DocumentDB. The entire service is a REST layer, and you can address all the resources in that service by simple REST protocols. Then for those, because not everybody likes talking native REST, we then take that REST layer and we wrap it up with language-specific SDKs. So we'll have a C# SDK that works well for .NET developers, or we'll have a Node SDK that works well for Node developers. So you can choose how you wish to connect to the service.
Yep. Now, today you'll see that we show the service in the portal. We do some stuff in code, right? You could also do this via the command line tools. So we have PowerShell, and we have the command line that works across Linux and Mac, all the different environments.
Or you can just, use the SDK and programmatically manage your service as well. So, as David mentioned, there's these document databases in the NoSQL world, and we're not the first. Azure DocumentDB is not the first document database. There are others out there. So, an interesting question is, how do we see Azure DocumentDB differing from the other offerings that are out there? And I think we differentiate ourselves on these 4 key tenets at the bottom. So the first one is really, it's a service. There's no spinning up VMs, there's no managing VMs, there's no setting up clusters or replicas or managing any of that stuff, or doing OS updates or
containers, whatever,
or Docker containers or whatever you want. It's just, hey, click a button, provision a service, and start using it. Really, really dead simple. But the other key thing here is that we're not just taking a product that was built for one kind of deployment model and then, installing on a VM and then managing that VM for you. This thing really has been designed from the ground up as a distributed service, right? So it gives us that ability to kind of run on commodity hardware, and gives us that fine-grained kind of control that we can step it up and step it down, and the pricing reflects that. So it really has been built as a first-class kind of distributed service.
Sure. So I think one of the coolest things that the service has, and a lot of new features have come out around this, is around indexing. So we'll show that in some of the demos today, but we build an entire indexing infrastructure that lets you start off with the data right away. Maybe you don't know how you'll shape your data. Maybe you'll have, like in the example slide, right now we have arrays underneath connect via and manage via. Well, maybe you want to change the shape of your data and follow different paths. So we'll see that right out of the box.
And that's one of the benefits of following a NoSQL schema-free kind of database, right? Is that I don't have to spend months. When I wake up in the morning and I just want to I have this crazy idea for building an app, I don't want to have to spend months kind of coming up with an ERD, doing a design and modeling my data and thinking about all the index paths. And, I just want to start writing my data. I've got my model, I've got an idea of what it looks like. I just want to be able to create that take some JSON, persist it to my database, and start working with it. I don't, and then have this evolve as my application evolves. And really, we've spent a lot of time on that indexing layer to make sure that you can just start off and use it.
Yep.
And then we give you the ability to kind of tweak and customize and control and manipulate that indexing layer as you learn more about your application and your workload. And as your models evolve, you can then go and evolve your indexing kind of at the same time.
Yep. And the database also allows you to choose your consistency. Everything from eventual consistency to absolute. I do a write, and all of the replicas are, we make sure we replicate before you return from your operation, like your insert operation.
So that's like the strong consistency that we're familiar with in relational databases, right?
Right, and you get to choose on a per insert basis, for instance.
Absolutely.
And the same applies to indexing.
Yep. Right. So yeah, we'll show you an example later where indexing, you can choose that indexing happens as I write the document. The index is written to at the same time, which means obviously that I can query for that document immediately. Or under high workload scenarios, you may want to defer that indexing to a later period. You just want to get those writes in as quickly as you can. So you can switch the indexing to a lazy mode, and then it'll kind of just lazy index.
So here we have the overall DocumentDB resource model. We create an account, and then we have databases under there. And under a database, we have a collection. Under a collection, we have documents. And we do have some other elements with users and stored procedures and triggers and user-defined functions, but really we're focusing today on this path of database, collection, and document.
Yep. So in terms of, we said it was a service and you consume a service, and what we've done, because it's a multi-tenanted service that you consume, we've got this notion called a request unit, which is a normalized charge that every operation is charged with. So whether you're doing an insert or you're doing a read or you're doing a complex query, every single operation has this request unit associated with it.
Right. And what's nice is this is very consistent. So if you do a write and it costs, let's say, 2 request units, you do the same write in the same conditions, it'll still cost 2 request units.
Yeah. And that allows me to kind of predict and do some capacity planning so that, I know I'll be able to get an idea at the end of the month. If I know I've got, this kind of document and I want to do 1,000 of these writes a day, I know what that request unit, what my total request units are going to be by the end of the month, right?
And what's nice is either through the portal or programmatically, we can adjust that, the tier from 250 to 2,500 request units per second. We can adjust that different hours of the day based on our traffic.
Absolutely. Right? And what's really nice as well is that this is not a hidden away value, and it's not something that's kind of like, in a black box and you never get access to it. It's reported to you. Every single request you do has a response, and one of the headers of that response is this charge. So you can actually very accurately measure what your request units are by just recording the charge on every single response.
And we'll see that.
Yeah.
So when we start out, you're building your app, and you don't want to think about indexing at first. We take care of that for you.
Yeah.
Right? We have default values for everything. So out of the box, if you think about JSON as a path, where you see we have some nested, /address/street, /address/city. Out of the box, if we have something that's numeric, we put it in a range index. If we see something that's a string, put it in a hash index. Now, that's our best guess, right? It's a good way to start.
And that's going to get you, 80, 85, 90% of the way, right? And then, we realize that we don't know, as a service provider, we don't know what your workload looks like. We don't know what your access patterns are like. We don't know what your load is like. So this is our default, but we allow you to choose other out-the-box defaults. And then we allow you to go in and customize every single aspect of that. And that's what we're going to spend the rest of this session kind of taking a look at is how once I've got to the point where I want to start optimizing that index, how do I kind of go about doing that?
Great. Well, let's do it.
Cool. So let's go dive into some demos and show you what we're talking about. So before I get stuck in there, this is the Azure portal. If you haven't seen the new preview portal before, welcome to the preview portal. So to create a new service, I simply go in and I go to data and storage, and I click there, and I can provision myself a new account. So I give myself a new account, so I can call this AzureCon. Nobody else has taken that one. So I can choose my subscription, I can choose my resource group, or let it do one for me. I can choose my location. So let me go and choose West US, for instance, because that's the closest to us. And then if that's all I need to be able to do, that's all you need for a document account. And I'm going to hit create a new group and hit create, right? And that's going to take a couple of minutes, and it'll create you an account. And once that account is created, here's one I've created before. You can jump into that one, and this one now gives you access to doing things like I can go in and I can create myself a database. Simply just doing that, I create myself a database, and there down here is a list of databases on this account. So here's a database we've created before, and as David said, remember there's that model, there's databases, collections. So under this database, here is a collection I've got called data, and you can see it's currently running at the S3 pricing performance. So if I click on data, here is the collection, and you can see some metrics about this collection. So you can kind of get an idea of how full this collection is. You see it's not very full, it's only 10 meg full out of my 10 gig. You can get some information about indexing policy, the pricing tier, and we'll have a look at all of that stuff in a bit. So if you go and take a quick look, here's a document explorer. So in this movies data, here is some of the data that we've imported. So we've got this notion of movies, we've got cinemas, what's showing where, etc. So if I click on cinema, you can have a look. There's some cinema data right there. And nicely in the portal, I can actually come in here and I can do something like change a zip code. I can edit my document, I can save it, and I've made a change to my document. So right here in the management portal, you can actually go and edit some documents. You can add a document, you can create a new document. By doing this, you can do a whole bunch of stuff in this portal.
And what about if you wanted to query a document?
So if you want to query a document, you can actually just go in here. There's a cool thing called a query explorer. So I can come in here and let's go run a quick query. Let's go and say,
So we're searching for a movie now.
So I'm searching for a movie with a title called Ant-Man. And there is the movie Ant-Man. So you can see that comes back. It's got some overview. It's got some stuff. If I wanted to search for a cinema, I could actually do the same thing right here.
Well, just curious, how much did that query cost?
So good point. Remember I said there's request units associated. So in the portal, you'll actually be able to see it. So right here, that query cost me 3.5 request unit or 3.15 request units. And you'll see if I run it again, if I run the same query again, you will see the exact same cost coming back every time.
And you return the entire document.
Yeah.
So maybe cost would go down if you return.
So the cost is based on a number of different things. One of them is the size of the document that we're parsing and sending back to you. So instead of saying, give me the whole document, maybe I just want to have the title, and maybe I just want the overview, right? So m.title and m.overview from movies. And if I run that query and I scroll across, there it is. So now I'm only bringing back the title and I'm bringing back the overview. And if I come and have a look here now, remember what that cost was. If I come and have a look here, you'll see that cost has gone down slightly. And the reason that cost has gone down is because we're parsing less data, packaging it up and sending it back as a result set.
Sure. So
that's why that charge has kind of gone down. Yep. But every time I run the same query and I get the same results back, the charge will be exactly the same.
Yep. So it's nice that you don't have to do that just in the portal. We might want to do that in code, right?
Yeah, so show me how to do this in code.
Okay, so what I have up on my screen, if we can see my screen, here we go.
There we go.
So this is just a little node application. All I had to do was bring in the DocumentDB package, right? Simple npm install of DocumentDB.
Yep.
And once I had my client set up, I created a query, same thing that you just did, with the title and overview, and I have a given title that I could pass in. And then what I do is I'll return the results, and there's actually a special header, XMS request charge, I'll return the cost.
Yep. So there's that same charge that I saw in the portal, you were seeing it, pulling it out of the headers collection, right?
Yeah, so you ran for Ant-Man, right?
Yeah.
Okay, so I just ran the query for Ant-Man, and what I did is I returned the title, and we returned the overview. I also returned the ID, so the cost might not be exact. What do you have, 2.97?
I got 2.97, you got 2.98. So the charge is slightly high because you returned slightly
All right, so
high.
0.01 for ID. At least we know that. So the thing is we could also query right out of the box for subpaths. So think about genre, and we know that genre is stored in an array. Yep. So every document will have an array of, maybe it's a comedy and a drama and who knows what. So in this case, here's my query, and I'm doing a self-join on the document against the genre.
And that query syntax there is fairly familiar to anyone who's worked with a relational database, right? Our query grammar is based on SQL. Yeah.
Yep. So I could say query genre. I don't know. Maybe we want drama. So and we capped it at just 2 movies.
Yep.
But here we go, returning 2 titles. So if we think about earlier when we were saying we have paths, so we have the /genre/
Yeah, absolutely. Yeah.
So
some things, like, I mean, you know, if you go and pull up one of my favorite movies, The Matrix, in your query over there.
Sure.
Query movie, The Matrix. You know, that overview is pretty long. You know, it's quite a whole paragraph and that kind of stuff. Are you ever going to go and do a query on that overview field?
No, I don't think I can memorize this.
No. So the nice thing there is that we'll come back to that in a sec. Let me say, if we jump back to my screen for a sec, you know, I wanted to do something simple. Like, I want to be able to say, well, show me all movies that are between. So let's go c.title. Sorry, it helps if I add a where clause. So where c.title is greater than or less than or equal. Oops, greater than or equal to A. Okay, and c.title is less than or equal to B. What do you think is going to happen when I run this query at this stage?
I don't know. I would hope that you get all the movies that begin with A.
Right. What's going to happen if I run that? I get an error. Right. Why?
Oh, I know.
Why am I getting that?
I think it was a result of a default index.
Right. Remember the default index, we said that we do range operations on numbers by default and hash operations on strings. Well, what I just try to do there is I just try to do a range operation on a string.
Do I win a prize?
You can get your prize afterwards. It's a cool JSON t-shirt is your prize. So what we need to do with that potentially is, all we need to do is we need to go to this indexing policy. So let's take a look at this indexing policy. And this is what that indexing policy looks like. So it's a JSON document that describes the indexing. And you can see here I'm running consistent, I'm running true, and here these are the paths that are included in my index. And by default, like David showed you earlier on the slides, the roots path, right, and everything underneath it, where we see, we're putting a hash index where we see strings, and we're doing a range index where we see numbers, okay? So if I wanted to change that, for instance, I wanted to do range operations on a string, all I have to do is say range operations on strings, save that, and we now have a new indexing policy, right? We also have these default indexing policies up here. So if you don't feel like editing JSON and that kind of stuff, you can actually just come in here, hit the button, and then it'll set it for you. So if I now go back to that Query Explorer, and I want to do something like I did last time, where c.title is greater than or equal to M, and c.title is less than or equal to N this time, all right? And I run that query now I get results, okay? Yep. Because now I've got an index, a range index on my strings, and therefore I've actually been able to hit that really nicely. I don't know if you saw, but when that error popped up, it actually said, remember when we did the error, it said, hey, there was no index on this. You can actually enable, you can force a scan. So we allow you to say, you know, for those ad hoc queries, most of the time I'm not going to do range operations on strings. But every now and then I might want to do a range operation on a string, and you don't want to go and create an index just for that one every now and then operation. We allow you to kind of specify that it's okay, this time do a range operation for me, right? So let's take a look at that overview stuff of the matrix, right? How would I actually ever go and say, well, c.overview, you've memorized the overview for the matrix, right? Can you tell me, can I type it in here?
It's something about Morpheus.
Oh, okay. So what do we do about these kinds of things? Now there's a bunch of stuff in here that I'm potentially never ever going to query on, right?
Right. So this isn't a practical thing that we'd ever search for. So let me show you an example here. Let's go to the portal. We will search for, we'll select m.title, m.overview, where m.overview equals documentary. So assuming we can actually search for a given overview. I mean, that's nice, but it's impractical. I'm never going to do it.
Yeah.
So what we actually can do is we can get rid of certain data that we don't want. And how do we do that? So we already saw, Ryan showed how he was able to change strings from a hash index to a range index. So in this case, I can actually define, remember earlier we had the included paths, and here we have a hash, and here we have a range, and these are using enumerated types, so a little bit different style than the strings.
Mm-hmm.
But
the point is the same thing that I was doing in the portal with the
exactly.
same editing the same JSON.
Yep.
You're just doing this through code, right?
It's identical.
Yeah.
So we also have an excluded paths. So what I can actually do is remove an entire path.
Cool.
So we could say something like exclude path, and we could pass it like overview and everything underneath the overview.
Cool.
So what's nice about doing this is now we have offloaded all this overview from the index. We've shrunk the index, and as you saw, the matrix overview is
and I see there it says index transform completed, which is kind of cool because David made a change to the index, and without taking the database offline or without kind of pausing access to the database or anything, we've transformed the index in the background. But you don't have to take your app offline. You don't have to kind of have any downtime. You can change these indexes. Obviously, our database is fairly small. It's only 10 meg. If you've got 10 gig of data, that index transform may take a couple of seconds. But in a couple of seconds' time, the index transform will have completed, and you're back to happy days.
Right. So now that I've removed overview from the index, if I were to search for an overview, it wouldn't find it. But we can still search for title, and we can still search.
The queries, the portal's working on my machine. So if we jump back to my machine and I kind of run that query that you were talking about. So there I'm kind of looking for that documentary of overview, right? And if I run that now, I get an error, right? And if I scroll down and kind of have a look at the error, it's tiny. But basically it's saying, hey, I'm trying to do an operation on a path that's been excluded from the index. So you can't actually do that. You could, again, override it and go do a scan if you wanted to, but those are really expensive. But the point is that that movie is actually still there. If I now went and searched for, what was the ID of that movie?
Well, you could just search for a title like The Matrix.
Yeah.
Right.
So, if I now go and search for the movie, it's actually still there. So The Matrix, and I run that now, you'll actually go see the document's still there. I can access it by the other paths, but if I tried to run, if I tried to get the overview where the movie is that, it's going to fail because that overview is now out of the path. Yeah. So that's pretty cool, and it's kind of pretty powerful. The nice thing about that is once you start understanding your application, if there are fields in your documents that you're never, ever going to query for, and these documents can get pretty big. They can be right up to 512K. If you've got 80% of that document you're never going to query on, well, that's 80% of that space that is taking up space in your index. It's costing you request units when you write the records. Yep. It's costing you request units potentially when you process the record and do queries. So it really does make sense once you start understanding how you use these things to go and exclude those paths. And then, if in 6 months' time you change your application and now you're actually including that path, well, then you just go back in and you kind of take out the exclusion for that path, and then we will re-index that for you.
Right.
Cool.
So we've talked a lot of indexes we've modified between range and hash, and we've removed paths, and we can add paths. We could do all that as much as we want. One other thing that a lot of people have asked for is spatial data.
Yeah, so if we kind of take a look here, and I'm just going to go and pull up what a cinema, I showed you earlier there was a cinema record, right? So let's just go pull up a cinema record. All right, if we run that, I'll show you what the cinema record has got this GeoJSON capability on it over here. There's GeoJSON on it over here. And that GeoJSON tells me that this is a type of point, and it's got a latitude or a longitude and a latitude on it, right? So what happens, how would I be able to, I'd want to be able to go and say, well, give me cinemas that are within a certain location of me. So because I don't want to remember writing a bunch of latitude and longitude coordinates, basically what I did is I mapped out the city of Redmond. And I said, hey, these are the polyglot coordinates for the city of Redmond. Okay, so here you'll see, this is GeoJSON again, you'll see type as a polygon, and these are the coordinates for the city of Redmond. And I'm saying, give me all cinemas that are within that city. Now, I have 7 cinemas in my database, okay? And if I run this query now, I get an error. And
Yeah,
that's because...
Yeah, let me show you. So one of the things that we need to do, if we switch back to my screen here, one thing we have to do is change our paths again. So I'm just going to regenerate or change our index. And again, we have our string. I'm setting up as a range just for fun. Numbers a range. And then anytime I see point, now that's going to be spatial.
Okay.
So what I can do is node geospatial index.
Cool. And then you see index transform completed again. So if we jump back here now and I run that query, this time I run the query and I get back that IPIC Redmond is within the city of Redmond.
Yep. Which
makes sense, right? IPIC Redmond's and the other cinemas that I may have are in Kirkland or Bellevue or Seattle or whatever the case may be. So the other thing that you can do with that is you can also say the other spatial kind of query that you can do on the server is you can do something that says this, and that's, hey, I want to get all cinemas that are within 2 miles, so 2 times 1,600, because GeoJSON works in meters, or latitudes and longitudes work in meters. So I want to get cinemas within 2 miles, and these coordinates over here are the coordinates where we're currently recording from. So run that query, and I will get back some different cinemas. So this time you'll see I get Regal Crossroads, I get IPIC Redmond.
Yep.
So now I get IPIC Redmond and Crossroads. So that means Crossroads is within 2 miles of where we are, but it's not in the city of Redmond. And that's why I never got it back in the first one. So that's the cool geospatial kind of capability that we've just recently added to DocumentDB.
Fantastic. So why don't we take a step back and recap all the things we just went through?
Sure, go for it.
So first, you had that demo. If you want to go back to that movie, right? This is our typical movie JSON object. We worked as just a sample of all the data we went through.
Yep.
And then first thing we looked at was default indexing.
The things that you can do.
Yep. Right. So search for a title, maybe search for vote average. Right. Both of these would work out of the box without changing anything.
Yep.
And we knew that we could do equality on strings, ranges on numbers. Okay. We even saw that we could follow paths.
Yep.
We had no problem there.
You can follow down the paths and query on those paths.
Yep.
That's pretty cool.
Yep. Now we ran into a little trouble when you tried to do a range. So we were able to modify the index type for strings.
Yep.
Now, one of the things that we showed was we just did a flat out default. Like for all strings, we just do range. Yep. That's probably not a practical thing. So because we get to specify paths, you could also say a particular path. Like
I want a range index on this path, but not a range index on that path.
Right. Maybe by default it's range, but or default it's a hash, but maybe for title it's range or.
Yeah. And that, again, it just depends on what your application is doing and if you want to kind of eke out the best for that application.
Sure.
But you can just start off very, very quickly and just start working, and it works for most.
Right. We already saw that unless you're searching for a one-word overview, it's not a very practical thing, right? Maybe a different tool like Azure Search is a better thing to search for words inside of an overview. So we saw how to remove something, and then we saw a few examples of the spatial data. We saw how to modify our index paths to support spatial. Right.
Yep. Yeah. So we kind of went through. Recap. That's the default that we used and we got out of the box. The different kinds of indexes. We took a look at hash, range, and spatial. We took a look at how to include and exclude paths. The one thing we didn't. There's 2 things here we didn't kind of cover in the demos, and that's because they're fairly difficult to demonstrate. But and that's this consistent versus lazy mode. And I spoke about it a little bit earlier. If I had a very write-heavy workload, I may, and I didn't need to query for the records immediately once they were written. I'd be okay, waiting a little bit for the index to catch up. I can actually switch the index mode to lazy. And that just says, hey, write the documents as quickly as you can and don't worry about updating the index. You can come around and update the index after the fact, after that write workload is tapering off. Now go and update the index.
Yep. And the other thing is automatic we didn't show.
Yeah.
So right now everything is just indexed with every operation. You could actually say the automatic is false, do a write and not have the index created and then do that later.
Yeah. So you can actually switch it to false, and then when you insert some documents, so maybe the majority of your documents they're logging records and you're okay to only read them by their ID and you don't ever want to query on them. So switch the index potentially off, and then every now and then there's a document that you write that you do want to index. You can use a directive to override that and tell the system to, hey, even though that collection is is not being indexed. I want you to index this one specific document, and we'll go and do that.
Yep.
And even when you're in true automatic mode, like we are at the moment, if there were certain documents I wanted to write that I didn't want indexed, I can use the same directive to tell the indexer, actually don't index this document. Just save it and persist it and replicate it and do all of those things, but actually don't go and index it.
Right. And then lastly, we showed how index transforms are on demand. You don't have to take your data offline. You don't have to recreate your collection. You just say, I want to change my indexes. It takes a little time, returns you a status when it's done.
But the nice thing is that even while that index transform is happening, so you'll see the progress, 10, 20, 30, 40, even before it gets to 100, you keep using the application. What may actually happen is you may get some inconsistent results. So you may go search for something that may not be there or may not be included in the result set because the index is busy transforming what's going on. But you can actually, your application will still work. So you don't actually have to take things offline even for a couple of seconds. Your app just keeps running.
Sure.
So as we wrap up, I mentioned that there is a couple of SDKs. So if you don't want to use the REST layer, we support .NET, Node, Java, and Python.
The community has some too, right? We have a Go language.
So we have a Go language. There's a Ruby SDK. There's a PHP SDK. So the community is stepping up and kind of writing SDKs. So if there is a language that we don't have and the community hasn't built yet, we'd love it if people out there, built us a C++ SDK or whatever the case may be.
By now, everybody has seen the portal, but it's at portal.azure.com.
Yeah. And then, something else people ask us for, they say, the portal's great and the tooling in Visual Studio's, it's there, but I just want to have a standalone kind of tool to be able to, like a, management studio to be able to go and kind of manage my database, run some queries, insert some documents, create a database, whatever. So there's a DocDB Studio. So you can actually just go to that URL, grab this DocDB Studio, install it, and use it offline.
Sure. Then we have the exploration playground, right? If you go to AKMS DocDB playground, you start playing with queries.
So it's a sandbox environment that we've got running, and we've loaded it with a bunch of data. So it's the US nutritional data set, and there's some volcano information and that kind of stuff. And there's some pre-baked queries that you can actually run and use, and there is actually some an environment that you can edit the query interactively and run and see what the results are on the fly.
Yep. And then you can go to build an app, right? I mean, that's the part that I like. No more portal, right?
Yeah. So DocDB Starter, that'll give you a bunch of tutorials. So a tutorial in Python, Node, .NET to get up and running and actually build your first to-do app using DocDB. Sure. And there's a bunch of help files and resources in there that you want to kind of go have a look at.
Right. And then we have tools for importing data.
Yeah. So we built an import tool. It's an open source tool. It's available on GitHub. You can contribute to it. What's nice is that the tool today supports a number of different sources that you can import data from. So you can import data from JSON files, CSV files, MongoDB, relational databases like SQL, all sorts of things. So you can import that data. If there's a source that you need that's not there, go to GitHub, grab the project, contribute a new source, and we'll happily accept that new source into the project. Not only can you import data, you can also export data using this tool. So if you wanted to kind of copy data from a dev environment or production environment to a dev environment, you could have DocumentDB as the source and DocumentDB as the destination, and you can move data from the one into the other.
Yep. All right, so we have our Twitter handles up here. There's the DocumentDB handle. You could bug Ryan and myself. If you're in a Stack Overflow and you want to ask a question, there's actually a tag, right?
Yep.
Azure-DocumentDB. There's some good activity there. And then we have links to both the Node and .NET SDKs.
Yeah, so you'll see, we've put two of them up there. If you're looking for the Java one, it'll be -Java on the end. If you're looking for the Python one, it'll be -Python on the end.
Yep. And then all the stuff that we showed today, the little code snippets, we created a little GitHub repo at the bottom there at AzureCon 2015. Go ahead, grab the code, have fun with it. Yep. We have a little walkthrough with all the examples as well.
Cool. And that's about it that we have for you today. Thank you for joining us. It's been fun. So thank you very much.
Yep, thanks.